Hello, this is lesson 22, our video notes. We are working with equivalent rational expressions. And the first thing we're going to do is identify values of a variable to prevent division by zero. Sometimes it's x, sometimes it's another variable. But to get started, you have to remember that in class we talked about how a rational expression is a polynomial in the numerator, or p, over another polynomial in the denominator, or q. And we said that q cannot be zero. It cannot equal zero. And so sometimes when we have a variable in our denominator, we have to solve for that variable so that we can find which values of the expression cannot be part of the domain. So for example, if we have 3 over x, the first thing you're going to do is set denominator to 0. Hr to 0. So you just set x is equal to 0. Now, we don't really have to solve for anything because it's already solved, but what this means is all the values for x can work except x cannot equal 0. So if we do plug in 0, then our whole expression is undefined, and so we need to call out which values make that function undefined. So let's take another example. Let's do 4x over 6x. And immediately my first reaction is to cancel out the x's because there's an x, and we can cancel it out to 1. However, the first thing you have to do is identify the values of x that make our denominator 0. So again, your first step is to set the denominator equal to 0. So we're going to set 6x is equal to 0, divide by 6 on both sides. And we get x is equal to 0. That means that any number we plug into this expression will work, except x cannot equal 0. If x is equal to 0, then the denominator becomes 0, and then we have this indeterminate form of some function over 0, which doesn't work. Now, if we want to simplify the expression now, we could definitely do that. We can take 4 over x, this is times x, and then this simplifies to 1, and we're left with 4 over 6. And if we, again, simplify the numerator and denominator, we can simplify it to 2 over 3. Another example I'm going to do is, I'm going to clear some space. We're going to do an example that is 2x plus 1 over 6x plus 3. Again, step 1, find the values of x that make the denominator 0. So 6x plus 3 is equal to 0. And then we have to subtract 3 on both sides to isolate x. And I'm just doing my good Algebra 1 skills to isolate x here. I'm going to subtract on both sides, then divide to isolate x. And I get that x cannot equal negative 1/2. Because if we plug in negative 1/2 into our denominator, it's going to turn our denominator equal to 0. So now let's simplify. And the numerator is already simplified for us. And then in the denominator, we're going to get 3, and then I'm going to get 2x plus 1. And now, because these are factors, there's a factor in the numerator, there's an invisible 1 right here, and there's a factor in the denominator. Now I can cancel out the 2 factors to get left with 1/3. Okay, let's move on to some more examples where the instructions say to reduce the following rational expressions to lowest terms and identify the values of the variable that must be excluded to prevent division by 0. Well, okay. We are going to need to reduce our expression, and we need to identify values to prevent division by 0. So even though this says and, we should actually do this first. We should do this identifying the values first, and then let's reduce. So step 1, let's identify the values that the variable must be to prevent division by 0. So I'm going to take my whole denominator, 2x plus 3 times x plus 1 equals 0, and now I'm going to use zero product property to separate these 2 factors to solve for x. So I have 2x plus 3 is equal to 0, and x plus 1 is equal to 0. Again, use my good Algebra 1 skills to isolate x, and I'm left with x is equal to negative 3 over 2. And on the side, I can just do this in 2 steps, and I'm going to have x is equal to negative 1. That means x cannot be equal to negative 3 halves or negative 1. All right, step 2, let's reduce this expression. I instinctively want to cancel out this x plus 1 and x plus 1. I think they're there and they're convenient and I can cancel it out just fine. But I have to remember that x plus 1 in this numerator is not a factor yet. So what we need to do is we need to expand the numerator to get 2x. I'm going to expand this numerator. 2x plus 2 over 2x plus 3 times x plus 1. You may be wondering why I didn't expand the denominator. It's because I want my numerator and denominator in factored form. I can cancel out factors. I cannot cancel out terms. So let's go back to simplifying. 2x plus 4, and then I get 2x plus 3 times x plus 1. And looks like they don't have any common factors in the numerator and denominator, so this would be my lowest term expression. You might be able to factor out the numerator, but I'm just going to, actually, I will factor out the numerator. X plus 2, and 2x plus 3, and x plus 1. Now I just have lots of factors in the numerator and denominator. Great. Let's work on example B. We have the same thing where the first step we're going to do, as I plug in my bamboo again, is we need to set the denominator equal to 0, and we need to find the values of x that make the denominator equal to 0. Okay, so step 1, take 5x squared plus 10x equal to 0. Now let's take out our greatest common factor, which is 5x, and we're left with x plus 2 is equal to 0. And now we're going to use zero product property to separate out our two factors so that we can solve for both x's. So we have 5x is equal to 0, and we have x plus 2 is equal to 0. So divide by 5, we get x is equal to 0. Subtract 2, and we get x is equal to negative 2. So in our rational expression here, x cannot be equal to 0 or negative 2, because then the world blows up. Or we just have an undefined value if x is equal to 0, x is equal to negative 2. Great. Part 2, we are going to reduce this expression to lowest terms. So I'm going to use my mental math in my numerator, and I'm going to factor it out. So it's x minus 3 and x plus 2. Does that work? Yes. Okay. And then I'm going to take my already factored form of the denominator. It helps that in the first step I factored it. And I'm going to, again, write out my factors. All right. The numerator is factored. That means there are only factors. And the denominator is factored. That means there are only factors. Now I can simplify my x plus 2 over x plus 2. And I'm left with x minus 3 over 5x. All right. Let's do another example with 3 minus x over x squared minus 9. So in this case, first step, let's set the denominator equal to 0. X squared minus 9 is equal to 0. This is an example of difference of squares, something that you should be more familiar with now. So it's going to be x minus 3 and x plus 3 is equal to 0. Again, use your zero product property. And we're going to separate this into two equations. X minus 3 equals 0, and x plus 3 is equal to 0. Plus 3, x is equal to 3. Minus 3, x is equal to negative 3. So in this expression, we cannot have, x cannot be equal to positive 3 nor negative 3. Okay, now let's simplify or reduce. This 3 minus x, we already know that the denominator is x minus 3 and x plus 3. So 3 minus x and x minus 3, they're similar, but they're not the same because they're switched and there's a negative sign and something's not working here. However, what we learned from our last video is we can factor out a negative 1 and we're left with negative 3 and a plus x. That also works because now that they are added together, we can switch them around. So we have negative 1, x minus 3, over, I'm going to put this x plus 3 over here, x plus 3 and x minus 3. Whenever I can, I'm going to rewrite my factors so that they line up together. So it's easier for me to write a big 1 right here so that I know that they have canceled out. So I'm left with 1, negative 1 over x plus 3. Okay? If you are one of those people that this part confuses you, to factor out negative 1, put a little caution sign, ask questions about it. These are good questions. Or if you need more examples on this, these are good examples to practice. Let's try one more example where we have 3y minus 3x, and then we have y squared minus 2y plus x squared. This looks a little funky because we have multiple variables in here, but I want you to follow along. Let's just try the same steps that we have been doing. Even though there are different variables, I'm not freaking out. I'm looking at it and I'm like, I wonder if I can solve this the way that I've solved the other ones and use those skills for this problem. So I'm going to take a look at this and I'm thinking, okay, if y squared minus 2xy plus x squared is my trinomial, what if I found factors of x squared and y squared that added to negative 2xy? I'm going to try this. I have x squared and I have y squared. And you don't have to do it this way, but I'm just thinking it. I'm trying to use tools that we already know so that I can attack this problem. I need factors of x squared, y squared that add up to negative 2xy. So what if I did negative xy and negative xy? Let's see. If I multiply these together, negative x times negative x is positive x squared. Y times y is y squared. So they multiply correctly. These are factors. And if I add these together, I'm going to have a combined negative 2y. So this may work. So now I'm going to do my reverse box method. Y squared, negative xy, and negative xy. And I'm going to factor out everything that I know. Okay, I'm double checking to see if this works. It looks like I have y minus x times y minus x is equal to 0. And if I FOIL this out, or I box method this out, I should get my y squared minus 2xy plus x squared equals 0 back. Okay, so now because there is a multiplicity of these two factors, we know that we can just use one of the factors to solve for. And that means that if I add x to both sides, I get y is equal to x. So this means that any value of y and x works in this expression, except when y is equal to x. So all numbers will make this expression work, except y cannot equal x. So if y is 2, x cannot also be 2, because it won't work. Okay, whew. We got that out of the way. Let's do step 2 where we are reducing. So luckily, we simplified the denominator already, and we have y minus x and y minus x. And now I can factor out a 3, and I still get y minus x, which is good because if I have one factor in the numerator and one factor in the denominator, and they're the same, I can cancel them out, and now I have 3 over y minus x. Okay, if you have questions, please write them at the end of your notes and then bring them to class. Otherwise, see you tomorrow. Bye.